chemistry and you are watching M Science.
This video is about the practical of rate of reaction. In our earlier videos, we had seen about the virtual readings and practical of titration and enthalpy, and this video we will continue about how to solve a rate of reaction practical worksheet with virtual rate readings, plotting of graph based on these readings, and then we will be learning about how to go for the further calculations of rate, and then at the end we'll discuss about what points to take care while writing the practical paper of rate, so that even though we have done full practical correctly but we don't lose marks. So here we have some readings based on the rate of reaction, and we will discuss it with the help of one of the past paper question of the rate of reaction. So here is one of our question based on the rate, where it says that in the acidic solution of iron 3 ions are reduced by the iodide ions to form iron 2 ions, and the iodide ions are oxidized to iodine. Now you can always pause the video and read the whole procedure, but the most important part here is that Fa1, Fa2, Fa3 and Fa4 are given with the name and the proper concentration also given. The starch X is an indicator. Now here we have a very long procedure. Based on this, I had performed the practical and had taken the reading which I'll be giving you now. So here is the method which you can read again, pause the video, and you can understand the whole procedure, where we have mixed all these Fa1, Fa2, Fa3, and with the help of the starch indicator we are measuring the rate of reaction. Here it says that stop the timing as soon as the solution turns blue-black after mixing all the solutions. Now here what are we changing? I'll brief you in short. What are we changing is the volume of Fa1 every time. So here in the first experiment we had taken Fa1 solution as 20 centimeter cube, and here in the experiment 2 you can see that we had to take 10 centimeter cube of Fa1 and then 10 centimeter cube of distilled water mixed with it. So that shows that we are reducing the concentration to half in this experiment. So here you can make out that what are we changing is the concentration of Fa1, and we are measuring the rate based on the various concentrations of Fa1. So here we can have a look at the solutions again. Fa1 is potassium iodide, Fa2 is ferric chloride, FeCl3, Fa3 is sodium thiosulfate, and the indicator is starch indicator. Now as we know that in the reaction iodine is produced, so as soon as the iodine is produced, a starch indicator is showing to give a blue-black color, and that is how we are going to measure the rate of reaction, the time taken to produce the blue-black color. That is, when the blue-black color appears, that's the time of the reaction to get over. So you can read the procedure and then we can go ahead with our next procedure. Here we are supposed to perform 5 experiments. Experiment 1 and 2 is given. Experiment 3 and 5, then we are supposed to choose the concentration. Here it says, let's read it. Carry out 3 further experiments to investigate how the reaction time changes with the different volumes of potassium iodide Fa1. The combined volume of Fa1 and the distilled water should always remain 20 centimeter cube, and the volume of Fa1 should not be less than 6 centimeter cube. So the highest volume what we can take is 20 centimeter cube, which we have taken in experiment 1. Experiment 2 we had taken 10 centimeter cube of Fa1, and then if we are not supposed to go below 6 centimeter cube, what I prefer is choose other experiments between these two so that the rate is measurable, that is the time taken to complete the reaction to a pure blue-black color is measurable. If we go little below, the time may be very less and error may be more. So percentage error increases if the time is too small. So I prefer to choose the further 3 readings between 20 centimeter cube to 10 centimeter cube. And then here is the formula given for rate of reaction, that is rate is equal to 1000 divided by the reaction time. And then let's go ahead. What is the further question? It says we need to tabulate the readings here in the space given and then plot a graph further. So here we are going to tabulate the readings, and I am showing you the starting out part of the question again, where it says that on page 4 you will need to include the volume of Fa1, volume of water, reaction time and the rate for each 5 experiments. So this is what we are going to tabulate: volume of Fa1, volume of water, reaction time and rate. So let's make a table based on these 4 quantities. So here I have already made a table and you can see. Then let's start labeling the columns. Here are the experiments. Then first column I'll label it as an Fa1 volume in centimeter cube. I should always write the unit. So here I'll write volume of water again in centimeter cube. You can make table little bigger or write in a smaller handwriting here. Then next comes is time in seconds, and then at the end we need to write the rate. Now rate, unit of rate is per second, so I'm writing it as s power minus 1. And remember, we need to write the units in the labels of each column of the table, because all those units carries marks. So proper labeling and units has marks for the table. Now for the experiment 1, 2, 3, 4 and 5, here let's start writing the readings. So the volume of Fa1 in experiment 1 was 20 centimeter cube. Now I don't need to write centimeter cube besides here because it's already labeled in the heading. So 20 centimeter cube, and volume of water was 0 here. Next experiment was 10 and the volume of water also 10. Now what I had chosen earlier was the volume between 20 and 10. So I am starting with the 12, 14 and 16 centimeter cube of Fa1. So total volume of Fa1 and water should be 20. So here I should write 8 centimeter cube. For the experiment 4 I should write 6, and for experiment 5 I should write 4 centimeter cube. And so this is how I'm going to make the table for the first 2 columns. Now about the time, what I had measured was 9 seconds for the first experiment. Now we should be writing the time in the nearest second. So suppose if I had the time 1 minute and 4 seconds, so in that case 1 minute and 4 seconds, so I should write it in seconds, nearest seconds. So I should be writing 64 seconds rather than writing 1 minute and 4 seconds. So this is how you're going to convert it into seconds if you get the answer in minutes. But here we are getting it in seconds itself directly. So I'm writing 9 seconds. Then it was 21 seconds for me. The next reading was 18 seconds. Next was 16 and then 14 seconds. These are the timings which I had measured during the performance of the experiment. Now the rate is what is given here. That's the formula we have to apply. So if we calculate, divide all the time by 1000, 1000 divided by the time, we get the answer in the first is 111.1 per second. Now I would prefer writing it to 3 significant figures or up to 2 decimal places, whatever is comfortable we can write. So minimum of 3 significant figures or up to 2 decimal places should be written. You can write it up to 2 to 4 significant figures also, because these significant figures are also important if we want to score full in this tabulation. So for my next reading, the answer is 42.62 second rate per second, that is. For the next it is 55, so 55.56, 55.56. The next is 62.50, that's the rate for my fourth experiment. And for the fifth experiment, the answer for the rate is 71, sorry, it's written 71.49. So this is the calculation of the rate using the formula given here. I had erased my few of the readings and rewritten because it was little dirty looking, so I made a correction. Now let's go ahead with the further part of our question. It says that on the grid opposite, plot a graph of rate of reaction on the y-axis and the volume of Fa1 on the x-axis. Include the origin 0, 0 in your scales. Circle any points you consider is anomalous and draw a line of best fit. So here is our graph, but it won't come on our screen, so let me make it a little smaller. So here is our graph, great smaller, including in the given screen, and we are supposed to write volume of Fa1 in centimeter cube on x-axis here, and on y-axis we are supposed to write the rate. So rate in seconds per second, so that should be my label on y-axis. And again, we need to be careful that we need to choose a scale in such a way that it covers more than half the grid, as I had mentioned it in an earlier video also. So let's choose the scale in such a way. So I am again pausing the video and choosing my scale so that it doesn't take a lot of time. So here is our scale ready, where you can see that on x-axis I have chosen as 4, 8, 12, 16 and 20 centimeter cube of Fa1, and on the y-axis I have included 20, 40, 60, 80, 100 and 120 of rate per second, and covering more than half the grid. Actually I prefer choosing a scale which covers even more than the grid, but then here we are left with no choice, as they had said in the question to include 0 on the axis. So we need to include the 0, and accordingly now the scale is chosen. And now let's plot the points. So now our points are also plotted and we are supposed to draw a best fit line, but now you can see here that I have drawn crosses. To show you I have made it in red, but you need to make it in a dark black pencil. And now we need to choose a best fit line. As we are including 0 in our scale, we need to pass our line through the origin, that is 0, 0. So let's draw a line now. So this is the line we have chosen, where we can see that almost 4 of the points are lying on the line, but one of the point is anomalous, and we can circle it because it was mentioned in the question that if any point is found anomalous, we can circle it. So here we have shown it with the help of a circle, the anomalous point. Now let's go ahead and read the question. The next part of the question shows that use your graph to calculate the time taken for the reaction would have taken if 5 centimeter cube of Fa1 had been used. Show on the grid how you obtained your answer. So first make out where is 5, and then we can extra plot to find out the time and the rate. So if we have a look on the scale, here is our 5, and accordingly if we extraplot it, then so if we extraplot it, we find a reading here somewhere which we can include as 21 or 22 per second. So that's the rate. Rate is 22 per second. Now that is the rate, but we needed time. So calculating time from the rate is, we need to use the formula which was given to us earlier. So according to that formula, time is equal to 1000 divided by the rate. So it should be 1000 divided by 22, and so the answer is 45.45, and we can write it as 45.45 itself, because here we don't need to round up in the seconds. So here is our answer, where we need to show the extraplot, as it carries 2 marks. Extraplot also has a mark, and the correct timing with the formula applied gives you 1 more mark. Now let's go ahead with the next sub question. Says that using the data of experiment 1 and 2, show by calculation that the volume of aqueous potassium iodide used was directly proportional to the concentration of iodide ion. So what do we need to prove is that if volume of Fa1 is more, then the concentration is also more. So let's prove that. How are we going to do this is, in Fa1, experiment 1, the Fa1 taken was 20 centimeter cube. Now if you go reverse and read the question, you will find that the total volume taken after mixing everything was 60 centimeter cube, including the Fa2, Fa3 and starch indicator. So that shows that the iodide ions were diluted by the factor of 3, because the volume increased 3 times. So if the concentration of iodide ions in 20 centimeter cube is 0.05 moles per dm cube, then it gets diluted 3 times. So here if we divide it by 3, we get the answer as 1.67 into 10 power minus 2 moles per dm cube. That is our answer for experiment 1. Now if we say experiment 2, the volume of Fa1 was taken as 10 centimeter cube, and that was diluted to 60 centimeter cube. That is the concentration of 0.05 moles per dm cube was diluted 6 times. So if we divide it by 6, we get the answer 0.83 into 10 power minus 2 moles per dm cube. That's the reason this proves that if we take higher volume, the concentration is also high. The volume is 20 centimeter cube and the concentration is 1.67 into 10 power minus 2 moles per dm cube. And if the volume is 10 centimeter cube, then the concentration is also lower. That is, the volume lower, concentration is also lower. So this proves that the volume of potassium iodide is directly proportional to the concentration of iodide ions. So we can write here as the volume decreases, concentration decreases. Volume decreases, concentration decreases. Now I am writing here to highlight few things in red and blue, but everything has to be written in either blue or black in your examination paper. Let's go ahead with the next sub question. It says that explain by referring to your graph or your table of results how the rate of reaction is affected by increase in the concentration of potassium iodide Fa1. So referring to the graph, we can write that as the graph is a straight inclined line, that is, we can say that as the gradient increases. so the rate increases. So we can say that as graph is a straight inclined line, rate of reaction is directly proportional to the concentration of Fa1. I'm writing in short, but you have to write it fully. So this is how we write. If it's a curved line, then we can't say it's a directly proportional, but here as we have got a straight inclined line, we can write rate reaction is directly proportional to the concentration of Fa1. Now let's go ahead with the last sub question, where it says that the thiosulfate ion can reduce iron 3 ions and also react with the acid to form sulfur, sulfur dioxide and water. Write an ionic equation for the reaction between thiosulfate ion, hydrogen ions, and the aqueous solution includes state symbols. So reactants are thiosulfate ions, that is S2O3 2 minus ions, including the hydrogen ions of the acid. Now what are the products formed here is sulfur dioxide and water. So these are the products formed. Now including the state symbols is written, so as we know that both the reactants are in aqueous form. So let's write aqueous here. Now sulfur should be in the solid form. Sulfur dioxide is, you can either write gas or aqueous. I am writing gas here. And water, we know it's a liquid state. So this is the ionic equation for the reaction of sulfate ions with the hydrogen ions. Now the next sub question and the last one says a student carries out the same investigation as in A. The solutions are mixed in a different order. The student places Fa1 and appropriate volume of distilled water in one beaker and all other reactants in the second beaker. The student then transfers the mixture of the second beaker to the first and starts the timing. Tick the box of the statement you consider correct. Explain your answer. Actually, we can tick any box as per our thought, but we need to give a valid reason here. I can say that two methods are equally good. Why? Because the thiosulfate volume was very less, so it won't increase the rate or affect the rate much. But I would say that the first one, the student's method, was better. Why? Because it's easy to transfer the solutions then by using the measuring cylinder. So that is better and gives a quick answer, quick result. So by using the measuring cylinder, that's what I am writing, measuring cylinder. So give any valid reason and you'll get your answers. I hope this worksheet solving will be very useful to you.